Chapter 6 Valuing Bonds. This is part 1 of Chapter 6. Following are the learning objectives of this presentation. After going through this presentation, students would be able to understand the bond structure. They would be able to understand rates of return on bonds. And later on, students would be able to ask questions such as, are bonds perfectly safe? What is the meaning of interest rate risk and default risk? And students would be able to also understand real versus nominal returns on bonds. So here are some basics in bonds. First of all, a bond has an issuer. Issuer is a person or an organization that is borrowing the money by circulating the piece of paper called bond. So a bond is like an IOU in which the person who is issuing the bond is borrowing the money against a written contract which is written on the bond. The contract may have specified payments at certain intervals like interest payments, and in bond terminology certain payments are guaranteed and these are called coupons. A bondholder is a person or an organization that owns the bond and they're entitled to these specified payments we talked about from the issuer of the bond. So the issuer is the borrower, the bondholder essentially is the lender, and the payments go to the bondholder. The face value of the bond, or the par value, or simply the par of the bond, is the value at which the issuer of the bond borrows money for every bond that they issue. For example, if the borrower or the issuer has issued a bond at a face value of 100, so when they issue the bond, they will receive $100 for every bond that they issue. We'll learn in future that the price of the bond may not remain at $100 at all. It will keep fluctuating with market conditions. But market conditions will not change the face value of the bond or the price of the bond at which the bond was first issued. The face value is also the value which the issuer or the borrower of the bond will pay the bondholder at maturity. So if the issuer has borrowed $100, promises 5% coupon for 10 years, then the issuer will return the $100 after 10 years, but in the interim, pay $5 every year as interest or coupon, as we'll say in bond terminology. So the coupon is a promised dollar payments that the issuer has promised. The coupon rate is a percent of the face value that the issuer has promised. So when we said the 5% value was the coupon rate, or $5 per $100 were the promised payments made by the issuer. So the coupon payments are always a percent of the face value. Now let's recall a n-year annuity. For n years, the present value of an annuity is cash flow 1 divided by 1 plus rate to the power 1, cash flow 2 divided by 1 plus rate to the power 2, where rate isn't percent or decimals. Here the rate is an actual number divided by 100. And so on till cash flow n divided by 1 plus rate to the power n. Now, this is assuming that the annuity ends in n years. End as in end, ends in n as in this n years. So the person who is holding the bond will receive these n coupons or cash flows every year from 1 through n. And the present value, therefore, is essentially the price of the bond. The present value is coupon received in the first year divided by 1 plus r to the power 1. Coupon received in the second year divided by 1 plus r whole square. Coupon and the last cash flow has a par, or the face value returned from the issuer to the bondholder. So coupon plus par divided by 1 plus rate to the power t. That is how we calculate the present value or the price of a bond. Here is an example. Let's take a 10-year bond with 4 years left to maturity. Means it has already traveled 6 years and there are only 4 cash flows left in this bond. It pays 10% on a face value of $100, which means $10 at the end of every year. So with 4 years left to maturity, we'll have $10 at the end of year 7, $10 at the end of year 8, $10 at the end of year 9, and $110 at the end of year 10. The last cash flow is 110 because it includes a $10 or 10% of the face value, and it includes the face value itself. So the cash flows look like this. Year 1, which is from today, or year 7 of the life of the bond, the cash flow is 10 years. Year 1 from today, or year 7 in the life of the bond. That's important. Year 2 today, from today, or year 8 of the life of the bond, the bondholder receives another $10. Year 9 or year 3 from today, the bondholder will receive another $10. And finally, the bondholder will receive $110, which is $10 of coupon and $100 of the face value. So the present value is the price of the bond, is the discounted rate of these cash flows. 10 divided by 1 plus rate to the power 1, 10 divided by 1 plus rate squared, 10 divided by 1 plus rate to the power 3, and 110 divided by 1 plus rate to the power 4. Our job is to find out the rate or the price, whatever. Now, how are the bond prices linked with interest rates? Well, let's define YTM, the yield to maturity of a bond. The yield to maturity of the bond is that rate at which, if I discount all the cash flows that are originating from the bond, I will get the present value of the bond price. Now, in the previous slide, if I knew the price of the bond, then I would have to find out the rate at which the present value of these cash flows would be equal to the price. So here, that's what my YTM is. YTM is the prevailing interest rate for that term. For example, for the previous bond, it had 4 years left to its maturity. The YTM that will drive the present value of the cash flows to the price of the bond will be called the 4-year interest rate for the previous bond. So the YTM essentially is the prevailing interest rate for that term. Here's an example. The price of a 10-year bond is $975. Its par or face value is $1,000. So the bond was issued by the issuer at $1,000 at a coupon of 5%, which means 5% of 1,000 is $50. So the issuer has promised to pay the investors or the bondholders $50 per year for 10 years. And the last cash flow will be 1,000 plus $50 of coupon, 5% of 1,000. So 1,050 would be the last cash flow of this bond. Now, at t equals 0, the price is $975. So this is the present value of all the cash flows. And we've just constructed the cash flows as $50 every year and $10.50 at maturity. So what is the YTM of this bond? We'll have to create the equation and see what rate will fit in for the YTM. So 975 is 50 divided by 1 plus rate to the power 1, 1 plus rate, 50 divided by 1 plus rate to the power 2, 50 divided by 1 plus rate to the power 3, and so on and so forth. And the final cash flow is 1050 divided by 1 plus rate to the power 10. And the answer to that is 5.33%. So the rate 5.33% will drive the present value of these cash flows to the price of the bond, or $975. If interest rate rises to 6%, since 6 is in the denominator, the price will drop to 926.4. So as interest rates increase, price of the bond decreases. Let's look at a table. The table here, well, this YTM of a bond can be easily found out in Excel. And as we see here, as the YTM of the bond goes up, the price of the bond goes down, and vice versa. So as the interest rates increase, price decreases, and vice versa. So here are some more facts. The coupon rate, if that is equal to the YTM, then the price of the bond will be equal to the face value. That's a powerful assumption. So in this example, the coupon rate is 5%. If the YTM also was 5%, then the price you'd get for that bond would be $1,000, which is the par value or the face value of the bond. The second thing is, if YTM increases, and becomes greater than the coupon, the price will be less than the face value. In other words, we're saying that if the price is less than 1,000 for the previous bond, then the bond is trading at a discount to the face value. So all we can conclude is price and interest rates are inversely related. One goes up, the other goes down. The next thing is long-term bonds are more volatile than short-term bonds. Okay, now so far what we've seen is bonds are paying a coupon. Now discount or zero coupon bonds are the bonds that do not pay a coupon. So the bond price has to be discounted by the interest rates. So assume that we have a 10-year discount bond or a zero coupon bond. So it starts out by investor paying the issuer an amount. So it's a negative cash flow for the investor. And there are no cash flows between time t equals 0 through time t equals 2 years. Now, what is the face value of this bond? $1,000. It means that at maturity, this bond will give the investors $1,000. So what is the price at which YTM is 5%? Well, this is a case of simply finding out the present value using rate, time, and future value. So 1,000 divided by 1.05 square will be the present value of this bond or the price of this bond. So 1,000 divided by 1.05 square is 907.03. That's the price of the bond. To conclude, we saw coupon of a bond, which is a percent of the face value. We saw price of a bond, which is governed exclusively by interest rates of the YTM. The yield to maturity of the YTM is that rate at which, if we discount the cash flows of the bond, then we get the price, or the present value equals the price. And we also saw present and future values of bonds. Well, future value is present value times 1 plus rate to the power t. That's chapter 6, part 1. Thanks for listening.